Welcome to Spring LIB.
Hi, let us imagine a wall and a ladder, and let's say you are a painter at point P trying to paint this ladder. But unfortunately, the ladder starts slipping to the left at some velocity v naught. Let us imagine that the length of the ladder is L and the point P is the midpoint. So basically, you are sitting at the middle of the ladder. Now, what is the velocity, let's say, of you falling as the ladder is falling, as the ladder end, this end is moving with v naught to the left. So we know that if this is moving to the left, this is going to move down. So this is the constraint motion. And as we have discussed in problem 1 and any other problem for complex motion, compound motion, it can always be broken down into translation and rotation. So let's say we are sitting here. Let's name these points. So let's call this D. Let's call this C. So let's say that you are sitting at the point D. So if you're sitting at the point D, then basically, first of all, everything will be moving. So not from your perspective, but overall, to get the perspective from an observer which is at rest with respect to the whole thing, the ladder will be moving to the left with respect with velocity v naught, and from where you are sitting, this thing is fixed. Point D is fixed. So this is from your perspective. D is fixed, and you are only seeing the angular motion like this, where this is coming down. So if this is coming down, you can find out the direction by using the right hand rule, curling your fingers along this motion. So the omega will look like this, and if our coordinate system is, sorry, y is not horizontal, y is vertical. So this is x, this is y. So our omega is going down because our z-axis is coming up. X cross y is z. So if you take the cross product, z points up and omega is going clockwise, so it's pointing down. Okay. Now, with this in mind, let us first calculate the velocity of point C. So let us do a bit of geometry. So to find this, you will also need angle theta, because as this end of ladder slips, the angle theta will change, but you will need this angle theta at a given time to determine any of the velocities. So if this is theta, this is also theta, and this angle has to be 90 degrees because the rotational velocity is omega cross r, and our r vector is like this, and our omega is going down into the page. So to take the cross product, take your right hand, push your fingers through the page inside, because that's the direction of omega vector a, and then curl your fingers towards vector b, which is r, in this case shown by the thick arrow, long arrow, and then your thumb will show you the direction of your vr, vector vr. So we know that it's going to point in this direction. Okay, so if we assume that velocity of this point is vc, it's going to point downwards. We know that this velocity has to come from this quantity. So this, let's say the angular velocity is omega naught. So this is omega naught. What is the radius? The r will be just length, and then angle, since we have already determined it, it's going to be sine 90. So it's omega naught L. So we are just talking about the magnitude here now. So omega naught L, assuming both numbers are positive, it's just omega naught L. Okay. Now, so this is omega naught L, this is theta, and we know that this VC must come from omega naught L. So if this is theta, this is 90 degree minus theta. So this will be theta. So omega naught L cosine of theta should be equal to VC. This is one equation. Okay. Now we also know, because of this translational part, that if this is theta, then this is theta and VC is here. So this is 90 degree minus theta. So we also know from this picture that VC of cosine of 90 degree minus theta equals V naught of cosine theta. So VC equals V naught cot theta, because this is sine theta and this will go and divide here, cos theta by sine theta. So cos theta by sine theta is cot theta. So this is the other equation. So now hence we get omega naught L cos theta equals V naught cot theta, which is just cosine theta by sine theta. So cosine theta gets cancelled and we get omega naught equals V naught over L sine theta. So this is the angular velocity omega naught. Okay, now let's say somebody asks what is the velocity of the painter P. The velocity of painter P is again going to be a sum of translational plus rotational velocities. But in this case, since the motion is all constrained, and if we are looking at it from the point of view of sitting at point D, then basically it will have a velocity v naught moving towards left. And if this is our r at theta, then by cross product of omega, which is pointing inside the page, and then this r vector, we will figure out that do the cross product, point your fingers in, curl them towards the thick arrow, this thick arrow, you will find out that rotational velocity is going to point in this direction. So, and what will be the magnitude? The magnitude will be omega times omega naught times the radius is L by 2 times sine of 90 degree, which is just 1. So this will be equal to V naught over L sine theta times L over 2. So V naught over 2 sine theta. Okay, so what is the total velocity here? So the total velocity, so we should write this in terms of vectors. So these are the two vectors we are trying to add. V naught in minus I direction, and this is theta if this is 90, and so then this angle, since this is theta, this will be 90 degree minus theta, and this velocity is V naught. The speed, which is the magnitude of velocity, is V naught 2 sine theta, V naught over 2 sine theta. So we can break this into two components, one along this and one along this. So if we break this down, we can write this in terms of nice I and j components. So we do that. So then the total I component is V naught minus I plus this broken down along this. So cosine of 90 minus theta, which is sine theta. So V naught over 2 sine theta, and then cosine of 90 degree minus theta. This is in a positive direction. So I plus along, so this is the angular velocity, and the j component will be negative. So, and that will be V naught over 2 sine theta. So this is 90 minus theta. So this is theta. So this is cos theta. This times minus j, which is equal to, so cos 90 minus theta and sine theta cancels. So this is minus, so minus V naught plus V naught over 2 is just minus V naught over 2 I plus V naught over 2 cos theta over sine theta is cot theta, and this is minus, so let's just write minus here. So minus I minus j. So this velocity, if you look at the direction, and let's calculate correct numbers. So Let's calculate some numbers. So if theta is given as 60 degrees and let's say v naught is 2 meters per second, and let's say length is 10 meters, then omega naught is going to be 2 meters per second over 10 meters, and then sine of 60 is root 3 over 2. So meter cancels meter, and then 2 cancels 10. So this is 2 over 5 root 3 per second, and this is omega naught, and then our velocity of p is minus v naught over 2 will be minus 5 I minus v naught over 2 cot theta, so it's 5, and cotangent of 60 is basically it's cos over sine, so cos is half, sine is root 3 over 2, so it's 5 over root 3 actually, and root 3 is a number bigger than 1, so it's basically a vector which has some component here, and then which is negative I and then negative j here. So you are falling basically by parallelogram law of addition somewhere along this direction with this total speed. So if you want to calculate the magnitude you can take 5 common and then square root of 1 plus 1 by 3. So this will be the total magnitude of velocity will be 5 times square root of 4 over 3, which will be 5 times, let's just write square root of 2 or 3. This is the speed with which you are falling along this direction. So this is how, by separating motions into translation and rotation, you can figure out omega naught, and you can figure out velocity of any point actually if you know the distance from the fixed point you have chosen. Thank you.